a new view of the Pacific skies.
The Mitsubishi A6M, known as the Zero, was not just an aircraft. It was Japan's ultimate strategic gamble. It combined unprecedented range with extreme maneuverability, catching Allied forces completely off guard across thousands of miles of ocean. For the first 6 months of the war, the Zero maintained a kill ratio that seemed mathematically impossible to break.
Welcome to KAL Warfront. Today, we Mitsubishi A6 Zero.
To understand the Zero, we must understand the doctrine of attack spirit, where weight was the enemy of victory.
The Imperial Japanese Navy demanded a fighter that could outfly anything, yet operate from carriers without heavy landing gear.
Engineer Jiro Horikoshi faced a paradox: how to achieve 300 knots and 2,000 miles of range with limited horsepower.
The answer lay in Extra Super Duralumin, a secret alloy that allowed for a structure as light as paper.
Every gram was accounted for. Holes were drilled into structural frames to shave weight, compromising the airframe's ultimate structural integrity.
This obsession with lightness gave the Zero a wing loading so low it could turn inside any existing fighter.
But did this maneuverability come at too high a price for the pilots tasked with flying it into hell? Early encounters in China with the A6M had already hinted at a weapon system that redefined the rules of engagement.
By late 1941, the Model 21 was ready, equipped with folding wingtips for tight storage on the Imperial carriers.
Its mission: total air superiority over the Pacific. Its target: every Allied airfield from Wake Island to Darwin.
The shock of the Zero's performance led to a myth of invincibility that would last for nearly 2 years.
Could a machine designed for pure offense survive a war of attrition against an industrial giant like America? Tactical question: if you cannot outturn a Zero, how do you survive a dogfight when your life depends on it?
The answer would not come from better planes, but from a change in the very DNA of combat tactics.
Before the tactics evolved, the Zero reigned supreme, a silver ghost that turned the Pacific into a graveyard.
The Zero's dominance was built on the prowess of the world's most highly trained naval aviators of the era.
These men had hundreds of hours of combat experience from the Second Sino-Japanese War before the Pacific conflict began.
In the early battles of 1942, the Zero decimated the aging buffaloes and hurricanes defending the Dutch East Indies.
Allied pilots reported that the Zero seemed to defy gravity, performing loops that no other aircraft could follow. At the Battle of the Coral Sea, the Zero proved it could protect the fleet while simultaneously escorting bombers.
However, the Zero's long-range capability meant pilots spent 6 to 8 hours in a cramped, unheated cockpit.
Fatigue became a silent killer as the aircraft lacked an autopilot or advanced navigational aid for long over-water flight.
During the invasion of the Philippines, Zeros flew from Taiwan, a distance previously thought impossible for carrier-based fighters.
This was made possible by the 330-liter drop tank, a streamlined external fuel cell that could be discarded before combat.
Allied intelligence was baffled. They refused to believe a single-engine fighter had such reach, leading to catastrophic defensive failures.
But the Zero's armor, or lack thereof, was a secret the Japanese guarded with desperate intensity to maintain their psychological edge. In every dogfight, the Zero was a glass cannon. It could deal lethal damage, but could not take it.
Below 15,000 feet, the Spitfire was the undisputed king of the turn, able to outrate any contemporary fighter.
The 20mm Type 99 cannons in the wings provided the punch needed to down heavy bombers, but carried limited ammunition.
Pilots had to be marksmen. They would use the 7.7mm guns to range the target before committing the 20mm shells.
Tactical failure. What happens when the world's most agile fighter meets a pilot who refuses to play by the rules?
At speeds over 300 knots, the Zero's controls stiffened, and its lightweight wings reached their aerodynamic breaking point.
At speeds over 300 knots, the Zero's controls stiffened, and its lightweight wings reached their aerodynamic breaking point.
The Allied boom and zoom tactic was born. Dive, strike, and climb away. Never turn with a Zero.
Suddenly, the Zero's legendary maneuverability was negated by physics and a relentless focus on kinetic energy management.
The psychological wall of the invincible Zero began to crack over the jungles of Guadalcanal and the Aleutian Islands.
The hunter was becoming the hunted, and the Japanese industry had no plan B to replace its aging champion.
Let's talk firepower. The Bf-109E3 carried two 20mm cannons and two 7.92mm machine guns. To analyze the A6M, we must look at the heart of the beast, the Nakajima Sakai 14-cylinder radial engine.
While underpowered compared to the American Double Wasp, the Sakai was remarkably fuel-efficient and reliable in tropical humidity.
The airframe was a semi-monocoque design, where the skin itself carried much of the structural load, allowing for a thinner frame.
The cockpit was designed for maximum visibility. The pilot sat high, with a 360-degree view.
Its weaponry consisted of two 7.7mm Type 97 machine guns in the cowl and two 20mm Type 99 cannons.
The 20mm cannons had a low muzzle velocity, meaning the shells traveled in a high arc, making long-range hits difficult. Weight saving reached extreme levels. The A6M lacked self-sealing fuel tanks, a standard safety feature in European and American fighters.
This forced RAF pilots to get dangerously close, often within 150 yards, before opening fire for maximum effect.
A single incendiary round could turn the Zero into a flying torch, as the high-octane fuel ignited the magnesium-rich alloy.
Furthermore, the pilot had no back armor. A burst from a Browning .50 caliber would pass through the aircraft and the pilot.
This design philosophy valued the sword over the shield, assuming the pilot would never be hit if he flew perfectly.
The landing gear was wide set for stability on carriers, but used a low-pressure hydraulic system that was prone to leaks.
Technical detail. The Zero's propeller was a constant-speed Sumitomo Hamilton design, allowing for optimal engine RPM at various altitudes. However, at high altitudes above 20,000 feet, the Saka engine load power rapidly, leaving the Zero vulnerable to high-flying interceptors. In comparison, the F4F Wildcat was the rugged brawler, while the Zero was the fragile dancer. One took a beating, the other avoided it. The Zero's control cables were made of high-tension steel but were exposed in several areas, making them easy targets for ground fire. Logistical burden. Each Zero required hundreds of man-hours of skilled hand-fitting, making it difficult to replace combat losses quickly. As the war progressed, the quality of these components dropped, as raw materials like aluminum and high-grade steel became scarce. By 1943, the Zero was an aging design, forced to fight against a new generation of American engines with double its power.
Yet, the Japanese command refused to retire the A6M, believing that pilot skill could overcome any technical deficit.
The turning point for the Zero's mystery came in June 1942, with the Akutan Incident.
A nearly intact A6M2 was recovered by U.S. forces, allowing them to fly it, test it, and find its every weakness.
They discovered that at high speeds, the Zero could not roll to the right as easily as it could to the left.
This tactical data was distributed to every squadron in the Pacific, ending the era of Japanese aerial impunity.
At the Battle of Midway, the Zero's role as a carrier defender failed when the Thach Weave tactic was deployed.
Thach Weave used teamwork to bait the Zero into a trap, turning its maneuverability into a disadvantage.
Combat reality. The Zero's lack of a radio that actually worked meant pilots could not coordinate during the heat of battle.
In the meat grinder of Guadalcanal, the IJN lost its elite pilot corps. These men were irreplaceable, unlike the machines they flew.
Replacement pilots were sent to the front with only a fraction of the training, leading to a massive drop in combat effectiveness. The A6M Model 52 was introduced to fix the Zero's flaws, adding thicker wingskin and individual exhaust stacks for extra thrust.
But it was too little, too late. The A6M was still slower and less armed than the new US F-6F Hellcat.
In June 1944, during the Great Marianas Turkey Shoot, the Zero's obsolescence was laid bare for the world to see.
In a single day, Japan lost nearly 400 aircraft. The Zero was no longer a threat. It was a target.
Vulnerability point. The Zero's oxygen system was primitive and prone to freezing, causing pilots to black out at high altitudes. Without self-sealing tanks, the Zero could not fly through the concentrated flak of a U.S. carrier task force.
The Divine Wind, or kamikaze, was the final, desperate role for an aircraft that had run out of tactical options.
Thousands of Zeros were used in suicide attacks, trading the lives of young men for a temporary delay of the inevitable.
Zero began the war as a symbol of pride and ended it as a symbol of a nation's refusal to adapt. Despite its eventual failure, the A6M Zero fundamentally changed the requirements for all future naval fighter aircraft.
The Zero forced the United States to develop the multi-engine, multi-role philosophy that dominates modern carrier decks.
Strategically, the Zero was the ultimate offensive tool, but it lacked the defensive depth required for a multi-year global conflict. It taught the world that maneuverability is a secondary trait if the airframe cannot survive the first burst of fire. The legacy of Jiro Horikoshi's design lives on in the quest for extreme weight reduction in aerospace engineering.
Even today, the Zero is studied by military academies as a masterclass in compromise and the danger of over-specialization. Was the Zero a superweapon? No. It was a specialized tool for a specific type of war that Japan could not sustain.
It remains one of the most recognizable silhouettes in history, a testament to Japanese engineering and a warning of its limits.
The Zero was the lightning before the storm, a flash of brilliance that was eventually drowned by the tide of industry. Today, only a few flight-worthy Zeros remain, their Sakai engines a haunting reminder of a vanished era of flight.
To fly the Zero was to embrace the philosophy of the Bushido, to strike first, and to die with honor. But in the cold calculus of modern warfare, honor is no substitute for armor, and speed is no substitute for logistics.
We see the Zero's influence in the agility versus stealth debates of the 21st century. Some lessons never change. The Zero proved that a nation could leapfrog decades of technology in a single design cycle.
It also proved that such a leap is meaningless if it cannot be replicated at scale during the heat of war.
Every rivet on these planes was a heartbeat of a worker. Every flight was a gamble with physics.
As we look back, the Zero stands as a pinnacle of piston engine design, a masterwork of aluminum and courage.
Tactical question. If Japan had armored the Zero in 1942, would the war in the Pacific have lasted another year?
We will never know. What we do know is that the Zero's eclipse was as rapid as its rise.
This has been an in-depth analysis of the Mitsubishi A6M Zero, from the tactical front lines to the engineering table. Stay tuned for our next episode as we dissect the engines of the Luftwaffe.
Thank you for watching. Don't forget to like, subscribe, and share your thoughts in the comments below.
Which legendary weapon system should we analyze next? Your choice shapes the front.